Our objective in this lesson is to organize data in a frequency distribution table, both for ungrouped and grouped data. The government is encouraging everyone to be vaccinated against the COVID-19 virus. Suppose you have the liberty to choose the vaccine. To make sure that you choose the best one, you ask the elders and make a tally on their preferred vaccine. And here is the result. Now, which vaccine is most likely you will choose? If you are going to base your decision on this tally, then most likely you are going to choose Pfizer because it has the most number of votes. Data can be classified into two. The first one is the ungrouped data. These are the raw or unorganized data. Let's have an example. Scores in a short quiz of 20 randomly selected students are as follows. Here are the scores. I've just mentioned that these are unorganized data. If we want to organize this data, then it will now become grouped data. Grouped data is an organized data presented using frequency distribution. Now, I am going to show you how to make this raw data organized. We need a table with 3 columns. These are the scores in the quiz. So the first column is labeled as score. The second column is tally, and the third column is frequency. Let us start. The list score is 0, then we have 1, we have 2, we have 3, we have 4, and we have 5. Now for the tally, we'll start with the first one, 5. So 1 vertical line in the row of 5. And then we have 3, so 1 vertical line here. And then 0. And then we have 4. Another 0. Another 4. Then we have 2, 3, 1, 5, 4, 1, 2, 3, 5, 4, 3, 2, 5, and another 4. If it is already the 5th vertical line, then you'll make it a slant line over the 4 vertical lines. Now, for the frequency, we're just going to write the numerical value of the tally. So this is 2, this is also 2, this is 3, 4, this is 5, and this is 4. This is an example of frequency distribution for ungrouped data. What is frequency distribution table? It is a tabular arrangement of data by classes with corresponding frequencies. These are the terms associated with frequency distribution. We have classes. These are categories or groupings. Frequency, number of observations belonging to a particular class. Class interval, range of values of a class. Class width, numerical difference between two succeeding lower limits or two succeeding higher limits. Class limits, boundaries for each class. Class boundaries, exact expressions of the class limits. And class mark or class midpoint, midpoint of each class. You are going to understand this further as we go along with example. Here are the steps in constructing frequency distribution table. The first one is to determine the range. The range is equal to the highest value minus the lowest value. Second step, unless specified, decide on the number of classes. Usually, there are 5 to 20 classes. Having enough classes can show patterns in the data. The larger the data set, the more classes are needed. There is no specific rule on determining the number of classes, but there are some rules usually observed to guide us. Here is the first one. It is called the Sturgis rule, where k, the number of classes, is equal to 1 plus 3.3 times the logarithm of n, where n is the number of observations. Let us say our n is 30, so let us substitute 30 for n. Computing this in a calculator, it will give us 5.87. Round off, it is equal to 6. Another method is the 2 raised to k rule. In this rule, 2 raised to k should be greater than or equal to n. N here is the number of observation. So let us say our n again is 30. So 2 raised to k should be greater than or equal to 30. We are going to look for a value of k such that when we evaluate 2 raised to k, it should be greater than or equal to 30. Let us start with k equal to 0. So 2 raised to 0 is equal to 1. Is 1 greater than or equal to 30? No. Now let's have k equal to 1. So 2 raised to 1, that is equal to 2. Is 2 greater than or equal to 30? No. Let's have k is equal to 2. 2 raised to 2 is equal to 4. Is 4 greater than or equal to 30? Is still no. How about if our k is equal to 3? 2 cubed is equal to 8. Is 8 greater than or equal to 30? No. How about if k is equal to 4? 2 to the 4th is equal to 16. Is 16 greater than or equal to 30? Is still no. Now what if k is equal to 5? 2 to the 5th power is equal to 32. Is 32 greater than or equal to 30? Yes. Therefore, our k is equal to 5. So we're going to use 2 raised to 5. Again, 2 raised to 5 is equal to 32. And 32 is greater than 30. Therefore, our k is equal to 5. Another way, k is equal to the logarithm of n divided by the logarithm of 2. N again is the number of observations. So once again, let us say our n is equal to 30. So let us substitute 30 here. And this will give us 4.9. Round off, and it will give you 5. You may choose from any of these formulas to decide on your number of classes if not specified. Just make sure to follow the instruction of your teacher on which formula are you going to choose. Next step is to determine the class width. It has a formula. I'll discuss this in detail later with an example. Next step is to create a table with 5 columns. The label of those 5 columns are class interval, tally, F, class boundaries, and class mark. Step 5, determine the lowest class limit as well as the next lower class limits. Step 6, determine the upper class limits. Step 7, write the class boundaries. Step 8, determine the class marks. Step 9, tally the data. And last step, sum the frequency and check against the total number of observations. Let's have an example. In a survey of 20 grade 7 students, the following data were obtained. Each value represents the number of times they opened their Facebook app per day. Construct a frequency distribution table. So let's start with step 1. And that is to determine the range. Again, the range is equal to the highest value minus the lowest value. Our highest value is 22 and our lowest value is 5. 22 minus 5 is equal to 17. So 17 is our range. Step 2, decide on the number of classes, k, unless is specified. In this particular example, I'm going to use 2 raised to k rule. So we have 2 raised to k is greater than or equal to n. Again, here are our observations. Let us count. 1, 2, 3, 4, 5. How many rows? 1, 2, 3, 4. 5 times 4 is 20. So our n is equal to 20. So we're going to look for a value of k such that when we evaluate 2 raised to k, it should be greater than or equal to 20. So again, our k here is 5 because 2 raised to 5 is 32 and 32 is greater than 20. Ma'am, how about 2 raised to 4? 2 raised to 4 is only 16 and 16 is less than 20, not greater than. So 2 raised to 5 is 32 and 32 is greater than 20. Therefore, our k is equal to 5. Next step, determine the class width, letter I, of the class interval. Here is the formula. Range our answer in number 1, which is 17, and number of classes, which is our answer in number 2, which is 5. 17 divided by 5 is 3.4. It says here, round up to the next whole number. So the next whole number is 4. Next step, create a table, 5 columns, and number of rows depends on the number of classes. Label the columns. So here is our table. The labels are class limit, tally, F, class boundaries, and class mark. Let us recall our answer in number 2, the number of classes, which is k, and k is equal to 5. That is why we have 5 rows here. 1, 2, 3, 4, and 5. Next step is step 5. Determine the lowest class limit. So let's recall again our observation. Our lowest class limit is the smallest data value. And the smallest data value here is 5. So let's have our table. And our lowest value is 5. So we'll write 5 here. This is the lowest class limit. The next lower class limit is equal to the previous lower class limit plus the class width. Our previous lower class limit is 5 plus the class width. Recall our answer in step 3, I is equal to 4. So 5 plus 4, and that is equal to 9. This is our next lower class limit. So we'll write it here. The next lower class limit is equal to the previous plus the class width. So the previous is 9 plus the class width is 4. 9 plus 4 is equal to 13. The next lower class limit is equal to the previous 13 plus the class width, which is 4. So 13 plus 4 is 17. The next lower class limit is equal to the previous, which is 17, plus the class width, which is equal to 4. 17 plus 4 is equal to 21. Next step is step 6. Determine the upper class limit. So let's have our table first. For the first upper class limit, simply subtract 1 from the second lower class limit. So our second lower class limit is 9. So 9 minus 1 is equal to 8. That would be our first upper class limit. So this will be 5 up to 8. Now, for the next upper limit, simply subtract 1 from the next lower limit. 13 minus 1 is 12, so this is 9 to 12. Next upper class limit, simply subtract 1 from the next lower class limit. 17 minus 1 is equal to 16, so this is 13 to 16. The next upper class limit is 21 minus 1, so that would be 20. Now, how about this one? We do not have the next lower class limit here. So what we are going to do is recall our class width. I is equal to 4. The class width is the difference of two succeeding lower limits or two succeeding upper limits. Take a look. 9 minus 5 is equal to 4. 12 minus 8 is also equal to 4. 13 minus 9 is 4. 16 minus 12 is 4. 17 minus 13 is 4. 20 minus 16 is 4. 21 minus 17 is 4. So what should be the number here? It should be 24 because 24 minus 20 is 4. There is actually a pattern. You will see it. 8, 12, 16, 20. So the next one is 24. Next step is step 7. Write the class boundaries by subtracting 0.5 from each lower class limit and adding 0.5 to the upper class limit. Again, here is our table. We now have the lower class limits and upper class limits. Next one is the class boundaries. For the lower class boundaries, all we have to do is to subtract 0.5 in our lower class limit. So 5 minus 0.5 is 4.5. For the upper class boundary, we simply have to add 0.5 in our upper class limit. So 8 plus 0.5 is 8.5. So here, lower class limit, 9 minus 0.5 is 8.5. Upper class limit, 12 plus 0.5 is 12.5. 13 minus 0.5 is 12.5. 16 plus 0.5 is 16.5. 17 minus 0.5 is 16.5. 20 plus 0.5 is 20.5. 21 minus 0.5 is 20.5. 24 plus 0.5 is 24.5. We now have our class boundaries. Notice that these are the exact limits of each class. The previous upper class limit is the next lower class limit. 12.5 is the next lower class limit. 16.5 is the next lower class limit. 20.5 is the next lower class limit. Step 8. Determine the class mark. So we have the formula here. Again, let's recall our table. We now have the class limits as well as the class boundaries. For the class mark, we simply have to add the lower limit and the upper limit and then divided by 2. Let's have an example. 5 plus 8 divided by 2 is equal to 6.5. So that is our class mark. Next, 9 plus 12 is 21 divided by 2 is 10.5. 13 plus 16 is 29 divided by 2 is 14.5. 17 plus 20 is 37 divided by 2 is 18.5. 21 plus 24 is 45 divided by 2 is 22.5. Next step, step 9, tally the data. Use sticks to tally the data, then write the numerical value in the frequency column. It has been a norm to use a slanted stick over 4 vertical sticks if the count reached 5, like this one. So again, here are our observations and our table. So let's start. Let's have the tally. Our first data is 10, and 10 belongs to the limit of 9 to 12. So one vertical line here. Next one is 8 here. We have 6 also here. Then we have 14 belongs to 13 to 16 class limit. Then we have 22. It belongs to 21 to 24 class limit. Then we have 13. It belongs here. 17. It belongs here. 19 also here. 11. We have it here. And then we have 9 also here. And then 18 we have here. 14 here. 13 also here, 12 here, 15 belongs here. It already reached 5, so we're going to make a slanted stick over the 4 vertical lines. Another 15, so another one here. 5, we have one here. 11 here. 16 here. 11 here. Now, for the frequency, let's have the numerical value. This is 3. This one is 6. This one is 7. This one is 3. And this one is 1. Last step is step 10. Sum the frequency and check against the total number of observations. Again, here are our observations. We have how many? 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 times 4 is 20. We have 20 observations. Again, our table. So we're just going to sum up the frequency. 3 plus 6 is 9. 9 plus 7 is 16. 16 plus 3 is 19. And 19 plus 1 is 20. This is our N, the total number of observations, and they are equal. For the summary, again, here are the steps in constructing frequency distribution table. Step 1, determine the range. Step 2, determine the number of classes. Step 3, determine the class width. Step 4, create the table. Step 5, determine the lower class limits. Step 6, determine the upper limits. 7, write the class boundaries. 8, determine the class marks. 9, tally the data. And 10, sum the frequency and check against the total number of observations. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Construct a frequency distribution table. The security guard recorded the ages of people from the contact tracing form that visited the drugstore. So here are the ages of the people who visited the drugstore. Step 1, let's determine the range. Our highest value is 68 and our lowest value is 18. 68 minus 18 is equal to 50. Step 2, let us decide on the number of classes. This time, I'm going to use the Sturgis rule. Let us count the number of observations. We have 1, 2, 3, 4, 5, 6. How many rows? 1, 2, 3, 4, 5. So 6 times 5 is equal to 30. So our N is equal to 30. Let us compute this in a calculator and this will give us 5.87. Round off, this is equal to 6. Step 3, determine the class width. So again, here is our formula. The range is our answer in step 1 and that is equal to 50. And the number of classes is our answer in step 2 and that is equal to 6. 50 divided by 6 is 8.33. Round up to the next whole number. This is equal to 9. So we have 9 classes. Step 4, create a table. 5 columns and the number of rows depends on the number of classes. Let us recall our answer in step 2. Number of classes, K is equal to 6. That is why we have 6 rows. 1, 2, 3, 4, 5, 6. For the columns, they are already labeled class limits, tally, F, class boundaries, and class mark. Next step is to determine the lowest class limit. That is the lowest value in our observation. And again, that is 18. This time, I'll start from the bottom. The next lower class limit is equal to the previous lower class limit plus the class width. The class width is our answer in step 3 and that is equal to 9. So we have the previous lower class limit, that would be 18, plus 9, that is equal to 27. This is our next lower class limit. So I'll put it here, 27. For the next lower class limit, that would be 27 plus 9 and that is 36. Next, 36 plus 9, that is 45. Next, 45 plus 9, that is 54. Next, 54 plus 9, that is 63. Step 6, let's determine the upper class limit. For the first upper class limit, simply subtract 1 from the second lower class limit. So 27 minus 1 is 26. So this is 18 to 26. 36 minus 1 is 35. So this is 27 to 35. 45 minus 1 is 44. So this is 36 to 44. 54 minus 1 is 53. So this is 45 to 53. 63 minus 1 is 62. So this is 54 to 62. Now, how about the last upper class limit? Recall the class width. I is equal to 9. The difference of 2 consecutive lower limits or 2 consecutive upper limits is equal to the class width. Take a look. 35 minus 26 is equal to 9. 44 minus 35 is equal to 9. 53 minus 44 is equal to 9. 62 minus 53 is equal to 9. So to determine the next upper class limit, 62 plus 9 is equal to 71. Now we have the complete lower and upper class limits. Step 7, the class boundaries. For the lower class boundary, we simply have to subtract 0.5 from the lower class limit. 63 minus 0.5 is 62.5. For the upper class boundary, we simply have to add 0.5 to the upper class limit. 71 plus 0.5 is 71.5. 54 minus 0.5 is 53.5. 62 plus 0.5 is 62.5. 45 minus 0.5 is 44.5. 53 plus 0.5 is 53.5. 36 minus 0.5 is 35.5. 44 plus 0.5 is 44.5. 27 minus 0.5 is 26.5. 35 minus 0.5 is 35.5. 18 minus 0.5 is 17.5. 26 plus 0.5 is 26.5. Step 8, determine the class mark. So we simply have to add the lower limit and the upper limit, then divide it by 2. Let's have the first one. 63 plus 71 divided by 2 is equal to 67. 54 plus 62 divided by 2 is equal to 58. 45 plus 53 divided by 2 is equal to 49. 36 plus 44 divided by 2 is equal to 40. 27 plus 35 divided by 2 is equal to 31. 18 plus 26 divided by 2 is equal to 22. Step 9, let us tally the data. The first one is 60, that would be here. Next one is 28, it will be here. Next one is 35, that will also be here. Next one is 49, here. Next one is 18, here. Next is 36, it would be here. 29 will be here. And then we have 48, 36, 20, 55, 68, 54, 43, 23, 33, 25, 50, 47, 42, 47. This is the fifth one, so slanted stick. 56, 63, 58, 28, 19, 22, 59, 63, and 62. Now for the frequency, the numerical value of the tally, this is 3, 7, 5, 4, 5, and 6. Last step, step 10, let us sum the frequency. It should be equal to the total number of the observations. 3 plus 7 is 10, plus 5 is 15, plus 4 is 19, plus 5 is 24, plus 6 is equal to 30. This is our number of observation, 30. They are equal. Gets? Our next lesson is presentation of data.